Alrighty, good morning, Science 10s. So today we're going to be talking about kinetic energy. And kinetic energy is just simply the energy of moving objects. So any objects that are in motion are going to have kinetic energy. So looking at these diagrams here, there's a golfer. The golfer's swinging the club. The club is in motion, so that club has kinetic energy. Look at the body of the golfer. It's not staying the same, right? The body is moving and therefore has kinetic energy. When the golfer is hitting the ball, there's a force being exerted on the ball, and therefore you're doing work on the ball because it's moving through a distance. So the ball has energy, it has kinetic energy. So, in order for an object to have kinetic energy, it's got to move. So, it's got to have a speed of some sort. And everything is made of matter, and matter has mass. So, when we look at the formula for kinetic energy, we can see that kinetic energy, or EK, is equal to 1/2 times the mass, m, of the object. Typically, that's in kilograms, times the speed of the object, but notice this is times speed squared. Okay, so that becomes very important when you're doing your calculations. So kinetic energy, 1/2 times the mass times the speed, which is typically in meters per second, squared, will give us a value of kilograms meters squared per second squared, which we know is a derived unit for joules. Just a quick reminder as well, you have this in your data booklet. So on our last page on our data booklet, last day we talked about potential energy, stored energy. Now we're talking about kinetic energy, the energy of things in motion, 1/2 mv squared. Okay, so let's take a look at some examples. Excuse me. When we are doing our examples, anytime you're doing a physics question, always write out your formula, substitute in your values in units, plug your values into your calculator, and solve. And then final answer must have those 4 things: sig digs, units, rounding, scientific notation. Okay, that's how you get full marks in physics. So here's an example problem, and we have a billiard ball. So you're playing pool. And we have the mass of the billiard ball is 0.300 kilograms. So that's 3 sig digs for that. And then we have the speed of the billiard ball, 20 meters per second. So again, 3 sig digs. And you're asked to calculate the kinetic energy, so EK. That's what we're trying to find. It's energy, so it's going to be in joules. So you write out your formula. EK is equal to 1/2 mv squared. Plug in your values. 1/2 times the mass, 0.300 kilograms, times V. Now you got to square it. So you have to use your calculator. Your calculator will often have an x squared function, and you must square your speed. Okay, that is a really important thing, because if you don't do that, you won't get the right answer. And this is where a lot of students make errors. So your calculator then will say 60, and then you have to understand that you need to put in sig digs, right? In terms of sig digs, you're going to have 3 significant digits. So 60.0, it's kilograms, meters squared per second squared, and we know that is a derived unit, so our final answer is 60.0 joules. Okay, so final answer, sig digs, rounding, scientific notation, and this is energy, so units are joules. Okay, so that's a nice, straight, easy, straightforward plug and chug. What if we have a little bit more challenging question, something like this, where we are asked to find the speed? So, well, same 4 steps: formula, substitution, plug it into your calculator, do the math, and then final answer. So this is a little bit different because we're looking for the speed of the object. V is what we're trying to find. We have the mass of the truck, 3 sig digs is 800 kgs, and we have the kinetic energy, 9.00 times 10 to the 4 joules. So remember that you always are writing out your formula. And then for this one, it's not just EK is 1/2 mv squared. You're actually going to have to rearrange the formula. And you write out your formula, it's the V that you're finding. But you don't want V squared, you have to find V. So first of all, let's just get rid of everything else on this side of the equation. So I'm multiplying 1/2 times m times V squared. So what do I need to do to cancel out the half and the m? I need to do the opposite operation. So opposite of multiply is to divide. So I'm dividing out 1/2 m. Now that will allow me to cancel out this side 1/2 and m. Excellent. So now I've got V squared. Remember, anything you do to one side of the equation, you now must do to the other side of the equation. So now I'm looking at this, and I've gotten rid of the 1/2 and the m, and I've got my V squared, and I'm thinking to myself, this is weird, this 1/2 on the bottom. So just FYI, 1 divided by 1/2, you can do that on your calculator. 1 divided by 1/2 is 2. So this is just another way of writing this. 2 times EK over m is equal to V squared. So again, we're almost there. We're looking for speed, not speed squared, but speed. So how do I get from V squared to V? I don't want V squared. Oh, yes, you have to take a square root. So if I take the square root of this side, I take the square root of that side. So what does that give me? It gives me the root of 2 times the EK, the kinetic energy, divided by the mass, is equal to, well, the root of V squared is V. So that's how they're coming up with this formula. Are you okay to write V is equal to EK over 1/2 m? Absolutely. But I just don't like it as much in that. You can totally do it, okay, but then you're having to divide by 1/2. Okay, so both are acceptable. I would accept both, but I'm just going to tell you that this one is actually easier to do on your calculator when you're doing it. Okay, so then now that you've got your formula written out, well, it took us a while to get there, right? So always, always, always show the original formula, the not rearranged. Get marks just for writing the formula, just for copying it from your data booklet. And then you rearrange. And once you have rearranged, now you can go ahead and forward and solve the question. So that means you're plugging in your kinetic energy, which we have given to us here. Now, notice, joules divided by kilograms gives us nothing to cancel. We can't do that. We have to convert to, remember we said joules is a made up unit. Well, what's it made up of? It's made up of kilograms, meters squared per second squared, divided by kilograms. Look at what units we can cancel. Kilograms on top and on bottom. So see here where I cancel this. Now I still got to take the square root of a meter squared per second squared. So when you do that, the square root of a meter squared is a meter. The square root of a second squared is a second. So that's how you end up with a unit of meters per second for the speed. Okay, so I'm going to do a couple of practice problems with you in our next video. Okay, so again, same 4 steps in each and every one of these physics problems. And the rearranging may take you a couple minutes, but you gotta do that in order for you to solve these questions. Okay, back with a second video in just a minute.